Hello everyone. This video is presented by Walchand College of Engineering Sangli and Club Electronics Engineer Students Association, that is ELISA. And this tutorial session is on hazard. I am Tejasri Ghogle introducing you to one of the important concept of digital electronics. So let's begin with it. Hazard. Start with the meaning. In digital electronics, hazard means unwanted switching transient that may appear at the output of circuit. And this is mainly because of different paths exhibit different propagation delays. Such transient is also called as glitch, which is caused by hazardous behavior of the logic circuit. And the hazard in the combinational circuit is a condition where a single variable change produces a momentary output change when the no output change should occur. So there are the two types of hazard, static hazard and the dynamic hazard. And the static hazard is again classified into the two types, static 0 and static 1. Here is a tree diagram of the hazard. So let's begin with the definitions. Talking about the static 1 hazard, it is a pair of input combinations that differ in only one input variable and both gives a one output. Means it is a possibility of one out at the output, but there is a glitch of the 0. And the static 0 is a pair of input combinations that differ in only one input variable and both give 0 output. Means the expected output is 0, but there is a glitch of 1 in output. So there may be a question in your mind, that is, what is mean by glitch? Because of the actual circuit delay, transient behavior of the logic circuit may differ from what is predicted by the steady state analysis. Means output is not as that much clear as we expected, and the circuit may produce a short pulses which we call as a glitch. So here is the static 1 hazard. Consider this gate circuit. Here we assume a condition that x is equals to y, which is equals to 1, and the z is changing from 1 to 0. So from this diagram we draw here a waveform. As x and y are constantly 1, here is a waveform, and the z is changing from 1 to 0. This is a waveform for the z. NOT gate gives a z bar, which is exactly complement of the z. So we may expect that z bar changes from 0 to 1 here, but it changes from 0 to 1 at this time, and this is we called as an inverter delay. The next term is ANDing of x and z bar. Here the output is 0 if one of the input is 0. So it is also not here we expect it changes from 0 to 1 here, but there is a delay so that it changes here. The next term is the y and z, ANDing of y and z, and here is the delay 2. And finally the function is ORing of xz bar and yz. So the output is like this, but we here expected the output should be 1, but there is a glitch of 0. We can see here it is a delay 3. So how to remove the hazard? Here is the K-map which is drawn from the equation. To remove the hazard, we must consider the redundant term, means the combination of two digits which we have not considered in earlier equation. So we made the group of these two and these two. So here we consider the group of these two ones, and the term is xy, and here is a redundant term which gives the static 1 output. Next, moving to the static 0 hazard, consider this gate circuitry, and w is equals to x is equals to y, which is equal to 0, and z is changing from 0 to 1. Here is a waveform for wxy. Which is constantly 1, and z changes from 0 to 1. Z bar is again complement, and this x bar and y bar are constantly 1, and the output of this OR gate is delayed here, and then y plus z, which is the ORing of y and z, is also delayed because of some internal circuitry. And as x, y are 0, x bar and y bar is constantly 1, and here is the output, which is 0, which we expected at 0, but there is a glitch of 1. Let's move towards how to remove this hazard. Again, we draw the KMF from the equation, and here also we consider the groups and the redundant term. This is a redundant term, and from this equation, that is product of sum equation, we find the term w plus x plus y, which is the redundant term, and which reduces this hazard. Next one is the dynamic hazard. And the dynamic hazard is the possibility of output changing more than once as a result of single output transition. So consider this diagram. In this, there are the gates of the different delays. In the earlier hazard, like static 0 and static 1, we consider the gates having the same delay, but in dynamic hazard we consider the gates of the different delays, and here output is not constantly 1 and not 0, it is changing. And this is all about the dynamic hazard. Here we summarize the all video, that is static 1 hazard, static 0 hazard, and how dynamic hazard is. This is all from us. For such a, please like, share and subscribe our video. Thank you so much.